Question 14. Find all the roots of the equation z to the power of 5 is equal to minus 16 plus 16 root 3i. So before we go on, let's just have a look at what this number actually is. And you can see there's a common factor of 16, which I'm going to factorize out. And then I'm left with minus 1 plus I root 3. What do you know? This is a 1, 2 root 3 triangle yet again. So what are we going to do? Well, I'm going to, because I've got z to the power of 5, I want to be able to write this in exponential form so I can use Demoivre's theorem, all right? So to do that, I need to know the argument and modulus of this number very, very quickly. So I'm just going to draw a quick sketch on the Argand diagram down here. And this Argand diagram is respectable, not fantastic. So you still need to draw better than this. But on a computer, it's a little tricky. And so what do I get? Well, I go minus 1 in the real direction, and I go up root 3 units along the imaginary axis, and that gives me a number about like this, right? And so this, if you look at this as a triangle, then this length is 1, this length is root 3, that means this length is 2, and because this is a right angle triangle, must also tell us that this angle in here is pi upon 3. So this angle, which will be our argument, is minus 2 pi upon 3. So we're happy, right? This means I'm actually asked to solve the equation z to the power of 5 is equal to 16, and then I'm going to write this in exponential form. Its modulus is 2, e to the I, argument, not minus, sorry, what am I thinking? Argument 2 pi upon 3. Right, so this is good. So what does that mean about z? It means z is equal to, and then I'm just going to move this inside, so I get 32 e to the I. And the important thing to remember, of course, is that it's not just 2 pi upon 3. I have to add 2k pi as well. And that whole thing's going to be to the power of 1/5, when k is an integer. So what does that give me? Well, that means that z is equal to, and the fifth root of 32, turns out 32 is 2 to the power of 5, so this is just 2, e to the I, and so if you move the 1/5 inside this, I would get 2 pi upon 15 plus 2 upon 5k pi, which is their answer, and all we have to do is specify the values of k that we're going to use. And I think you can see the smallest value of k that I can use is minus 2. So minus 2, minus 1, 0, 1, 2, the 5 consecutive values. And so this is my final answer.